This video is to show you how to use Genome Editor 2.0 to design a CRISPR project. The example used today is to insert a flag tag to the C-terminal human EGFR. In this design process, we'll design a guide RNA and design 2 oligos for the guide RNA cloning. Second, we will design a donor oligo for the homologous repair. And finally, we need to design a PCR primer pair for detection of the insertion. We'll start from after data preparation. We click on the Export to Genome Editing Design. The Genome Editing Design will show. As we mentioned before, the entire EGFR coding information was mapped to the contig from beginning to the end. And the exon information also stored in this pull-down menu. Each exon locations can be selected from this pull-down menu. To insert a flag tag to the C-terminal EGFR, we set the focal point at the stop codon TGA. So after setting the focal point, we click on the download sequence. And the sequence downstream of the TGA will be showing in this sequence box. And check whether the beginning of the 3 nucleotide is a termination codon TGA. And this indicates the download is correct. So the first step of designing is to design guide RNA. To do that, just select -50 from the genomic piece, and this 100 base pair will be showing in this sequence box. And export these 100 base pair sequence to the gRNA selection. All the potential gRNA in this 100 base pair are listed in this table. For this type of insertion, we need to select the guide RNA, cut the genomic DNA near the stop codon. So we pick the gRNA for cut location at 53 and 54. And this gRNA sequence will come into this sequence box. After select the gRNA sequence, we need to select the vector system. Again, we use the vector from Dr. Zhang Feng's lab, TX459, as a cloning vector. And then we click on the Design to Oligo for cloning. And to Oligo for this gRNA cloning will design. And the appropriate adapter sequence will add to the oligo. After design the oligo, just copy the sequence for ordering. So this completed the gRNA designing process. Just close this form and come back to gene editor design form. So the second designing process is to design a donor vector with a flag insertion. To do that, we go to genomic piece pull-down menu. We select minus or plus 75. So this 150 base pair sequence will show in this sequence box. And the half the part was highlighted before the TGA. Put the cursor right before the TGA. And then go to Building Unit pull-down menu. Select flag epitope So the flag epitope sequence will insert right before the TGA. And this sequence will be translated into peptide sequence. And check whether there's a flag sequence you want it. So this entire sequence now can be used as a donor repair oligos to introduce a flag tag at the C terminal. So copy the sequence and you can order the oligo now. Some people want to use 2 oligo forward or reverse. You can highlight the sequence and select reverse complement. And this reverse complement of the sequence will be shown in this sequence box. And then you can copy the sequence for ordering. So this completes the donor oligo design. And last, we want to design the PCR primers for the detection of the insertion. To do that, go to the genomic tree, select a little bit longer sequence along the stop codon. Select the -+450. So this 900 base pair will show in the sequence box. Click on the Export to Primer Design. So this 900 base pair will export to the primer design. And these 4 vertical bars define the region to pick the primers. The first pair is for forward, and the second pair is for reverse primer. So just click on Design. It will design 2 pairs of primers. Usually use 1 pair to do the PCR of your genomic DNA. If it fails, you can use 2nd pair, or you can combine 2 pairs as nested PCR to get your desired genomic sequence. So copy these 2 pairs of sequences for ordering. So up to now, we complete the entire process designing CRISPR project to insert a flag tag at the C terminal EGFR. Thank you for listening.